Today we'll be working on lesson 7.3 exponential and logarithmic functions. Now to glue this in your notebook, you just glue it just like 7.1 and 7.2. So let's go ahead and start on number 1. Now this is the logarithmic parent function, and as we all know, logarithmic functions have vertical asymptote. Now to know what the vertical asymptote is, it's always going to be x equals h. In this case, there's no parentheses, there's no h, so my asymptote, my vertical asymptote is x equals 0. So let's go ahead and represent it on our graph with a dotted vertical line going through 0. Now, in order to graph this function, we need a couple of points. So to do that, we have to remember that log of 1 is equal to 0. Log of the base with the argument matching the base, that would be a 1. So these are two rules that we learned in the logarithmic unit, and this will help you create the table. So if x is 1, so if you plug in 1 for x, log of 2, log base 2 of 1 is going to be 0, and log base 2 of 2, so if x is 2, my answer is going to be 1. Now another number that you can put is log, if you need a third point, of 1 over b, which is the reciprocal of the base, then the answer would be -1. So if I put half, which is the reciprocal of the base, then my answer would be -1. So these are 3 points that can help you graph your logarithmic functions. So let's go ahead and do that. The first point is 1, 0. The second point is 2, 1. And the third point is -half, or half -1. Now to graph this line, or this graph, I have to remember that it's going to be so close to my asymptote, to my vertical asymptote, but not touching it, and going through 3 points. So that's going to be my logarithmic function. Now, what would my domain be? As you can see, it's not extending beyond the vertical asymptote. So the vertical asymptote is my boundaries. So the domain is going to be from this asymptote all the way to plus infinity. So from 0, so remember that the vertical asymptote in this case is x equals 0, then my domain would be from 0 to infinity. Now infinity is not included, and since 0 is an asymptote, it's not included as well. My graph will never touch this vertical asymptote. Now if you look at the range, my graph is going all the way down, and this is going to extend up to plus infinity, so my range is going to be from -infinity to infinity. So this is how you graph the parent function. Now let's move on to number 2. Now in this case as well, I do not have an h. This number on the outside is going to be my k. So that's going to move my graph up 3. So let's write that down. If k is 3, then my graph is going to go up 3. Now the 2 on the outside is going to be my a, which is going to be stretching my graph. By a factor of 2. Now since there's no h, then my asymptote is x equals 0 as well, because h is 0. Keep that in mind. And the h is always going to be the number in the parentheses with the x. It's going to be part of the argument, like the case over here. See how the h is inside? Now let's go ahead and plot on our bigger graph. X equals 0, I'm going to represent that as a vertical dashed line. Now in order to graph the rest of the function, we need some points. Now there's a couple of methods to graph logarithmic functions, if you remember. One of them is to be dependent on the parent function table, and then add all the extra things, which is in this case the a and the k. So I'm going to try this method first. So I'm going to copy the parent function that I did earlier over here, and I'm going to ask myself that there's no h, so the x is not going to change. The x of my points is going to be the same, because h is the only thing that's going to affect my x. Now a is going to affect my y, and 3, which is k, is going to affect my y as well. So I'm going to be multiplying by 2 because a is being multiplied, and then I'm going to add 3. So 0 times 2 is a 2. 1 times 2 is a 2. No, 0 times 2 is not a 2, it's a 0. And negative 1 times 2 is a negative 2. And then after I multiply by 2, so after I'm done with the a, so you always go from left to right, you start with the a first and then the k, I have to add 3 to my new y. So if I add 3, it's going to be 0 plus 3, which is a 3, 2 plus 3, which is a 5, negative 2 plus 3, which is a 1, and that's going to be my new y. These are my new points. So my first point is going to be 1, 3, 2, 5, and half 1. And since the vertical asymptote is x equals 0, remember that my graph is going to be so close to it, and it's going to go through these points. Now if you compare this to the parent function, you will see that it is steeper. So that's how the stretching thing is represented. Now let's move on to the domain and range. Now the domain is going to be the same thing. It's going to be from the asymptote all the way to infinity. So the asymptote in this case is a 0, and the range is also going to be from negative infinity to infinity. So let's double check that. My graph does not go beyond the vertical asymptote, so yes, it's from 0 all the way to plus infinity. The range is from bottom to top, so yes, it's from negative infinity to infinity. Now let's move on to number 3. I would like you to pause the video and try number 3 on your own. Now I do hope you tried. Now let's go ahead and do it together. Now the vertical asymptote is going to be the h. In this case, the h is 1. So remember, you always take the opposite of the number on the inside. So x equals 1 would be my vertical asymptote. So I'm going to go ahead and represent it. So x equals 1 would be my vertical asymptote. I'm going to draw that with a green dashed line. So x equals 1. Now remember, I told you that there's another method to be graphing the points or getting the points. Instead of going back to the parent function and using that, you can try to plug in different points for x, or different numbers for x, that would give you a 2 on the inside, because you want it to match the base, or to give you a 1 on the inside, because log of 1, no matter what the base is, would be 0. So what would make the inside a 2? If x is 3, then 3 minus 1 is a 2. Log of 2 base 2, that would be a 1. So if x is 3, let me show you the work. So I'm going to show you the work here. So basically my negative log base 2 of 3 minus 1 would be a 2 plus 2. Now we know that log base 2 of 2 is a 1, so negative 1 plus 2 would be a 1, so the y would be a 1. So that's the work. And again, you can do this any way you like. You can use the parent function, you can use this method. Now you have to try to find an x value that would make the argument a 1. So if I put the x to be a 2, let's see what's going to happen. So negative log base 2 of 2 minus 1, which is a 1, plus 2. Now log of 1 is a 0 no matter what. So the answer is going to end up being a 2. So 2, 2. So let's go ahead and plot these 2 points, 3, 1, and 2, 2. I'm going to continue with the green. So 1, 2, 3, 3, 1. And 1, 2, 1, 2. So your graph is going to be so close to the vertical asymptote and going through these 2 points. Now the reason why, as you can see, it's starting from above, different from the other function, which is the blue, and starting from below, it's because the a in this case is a negative, so as you can see, it's being reflected. So this is an example of a reflected graph. So let's go ahead back to the transformation, and let's explain that the negative means that there will be a reflection in my graph, and this is shown. And the h being a 1, then it means that my graph is going to be moving to the right one, and my k being a 2, then it's going to go up 2. Now let's talk about the domain and range as well. Now the domain is going to be, again, from the asymptote, which is 1 to infinity, and the range is always going to be from negative infinity to infinity no matter what. So let's go ahead and check that. Now, even though my function is reflected, but it's again not going beyond the asymptote. So it's from 1 all the way to plus infinity. And the range also goes on forever downward and forever upward. So my range is going to be from negative infinity to plus infinity. So that's it for number 3. Please go ahead, pause the video, and try number 4. Now for number 4, I have an h of a negative 1, so my vertical asymptote is x equals negative 1. I'm going to directly write the domain. It's from the asymptote all the way to infinity, and the range is always going to be from negative infinity to infinity. So now I'm getting better. I can find the domain and range from the equation. Now let's go ahead and tell what each represent in the transformation. A is a 3, so then it's being stretched by a factor of 3. The h is a negative 1, so my graph is moving to the left one, and the asymptote, as you can see, will be moving to the left one. My k is a 2, so my graph is going up 2. Now for the table, you can use any method you like. You can do this method, which is basically depending on the parent function and applying the transformation, or you can just plug in different values. So I'm going to use the method of plugging different values. Now, I'm going to ask myself, what should x be so the inside would be a 1 if x is 0? So let's put in x equals 0 and let's show the work. 3 log base 2, x is 0, so I'm going to be left with a 1 plus 2. Log of 1 is a 0. Anything multiplied by 0 would be just 0, so my answer would be just 2. That's going to be my y. Now again, I need a value that make this equal to the base, the argument equal to the base, so this has to be a 2. If x is 1, this is 2. So let's write x equals 1, and let's show the work. 3 log base 2, 1 plus 1 is a 2, plus 2 on the outside. Log base 2 of 2 is a 1, so 3 times 1 is a 3, plus 2, which is a 5. So my y is a 5. So let's go ahead and present this on the graph. X equals negative 1. So let me represent that with a red. Let me choose a different color. Purple. So negative 1 would be my dashed line. X equals negative 1. And then my points are 0, 2. And then my other one would be 1, 5. And then what I'm going to do is I'm going to come so close to the asymptote, not touch it, and go through these 2 points. Now as you can see, so let me fix my graph. As you can see, this is going to be steeper than the one with the blue one, okay? So disregard this part. Steeper than, because it's stretched by a factor of 3, where the other one was stretched by a factor of 2. So it's going to be steeper than the blue one. So I do hope the logarithmic function, this part was a good review. Now we're going to move on to the exponential function. Now remember that exponential functions and logarithmic functions are going to be inverse functions. So if the logarithmic has a vertical asymptote, what does the exponential function have? A horizontal one. So my horizontal asymptote is going to be dependent on k. So y equals k would be my horizontal asymptote. In this case, there's no k. So my asymptote is y equals to 0. Let's go ahead and present that. So y equals 0 would be my horizontal dashed line. And now to be able to graph this line or this graph, I have to plug in different values. So if x is 0, 2 to the power 0 would be just 1. If x is 1, 2 to the power 1 would be just 2. So 2 points will be more than enough. So let me represent that by plotting it. So 0, 1 is going to be here, and 1, 2 is going to be here. So again, my graph is going to be so close to the asymptote and go up this way. Now, as you can see, in horizontally, there's nothing stopping my graph. So it goes on forever to the left, it continues up forever to the right as well. So my domain in this case is going to be from negative infinity to infinity. But my range is going to be limited. So if you look closely at your graph, it's not going beyond this asymptote. So my range from bottom to top would be from 0 all the way up to infinity. And since my graph is not touching the asymptote, so it's going to be from 0 to infinity, where 0 is not included. And that would be my parent function. Now let's move on to the number 6. In this case, I do have a k. The k is 1. So my horizontal asymptote is y equal to 1. So let me represent that with a horizontal dashed line. Let's get some points to plot this. So let's say if x is 0, let me show the work. So 2 times 2 to the power 0 would be just 1 plus 1. So 2 plus 1 is a 3. Now what if x is 1? So 2 times 2 to the power 1, which is a 2, plus 1, so that's a 5. So my 2 points are 0, 3, and 1, 5. And again, I graph so close to the asymptote and going through these 2 points. Now let's talk about the domain. The domain, as you can see, is from negative infinity to infinity, but my range is going to be from this asymptote all the way up. So my domain is negative infinity to infinity, and my range is going to be from the asymptote to infinity. And the transformation is going to be, it's going to be a is 2, so that's going to be a stretch by a factor of 2. The k is 1, so that's going up 1. And as you can see, the horizontal asymptote did move up 1 in comparison to the previous one. It went up 1. Now, there's no h because h is usually the number up there in the power along with the x, just like the problem in number 7. Okay, so go ahead, pause the video and try number 7 on your own. Now I do hope you tried, so let's go ahead and think of the horizontal asymptote. It's the k, which is in this case a negative 5. My domain is always going to be from negative infinity to infinity. As usual, the range, I'm going to stop for a second. I'm not going to do that because I have a negative and I would like to see what will the negative do to my graph. So let's go ahead and graph the y equals negative 5. Okay, so this is y equals negative 5. Now let's go ahead and plot some points so I can graph it and see how it will look. Let's go ahead and put a, let's say a negative 1, because like if it's to the power 4 or something, it's going to be a huge number that I will not be able to plot. So if x is a negative 1, what's going to happen? So let's show the work. I'm going to show it over here. So if it's negative 2 to the power negative 1 plus 3, which is a 2, minus 5. So that's going to be a negative 4 minus 5, and that's a negative 9. I can fit that in my on my coordinate plane. Now, what if x is a negative 2? So negative 2 and negative 2 plus 3 would be a 1 minus 5. So negative 2 minus 5 is a negative 7. So that is also something I can, so negative 2 is going to be negative 7. So this is also something I can plot. So what did we find? We found negative 1, negative 9, and negative 2, negative 7. So let's go ahead and plot them and see how they will look. Negative 1, negative 9. So it's going to be below my asymptote. And the other one is negative 2, negative 7. So then my graph is going to be very close to the asymptote, but going down. So see how the range now is different? Yes, the domain is going to be from negative infinity to infinity because this is going to extend. There's no limitation for it. It's going to go to the right. But the range, you cannot go beyond this. So, but it's going to go down. So it's from negative infinity all the way to negative 5. So this is how the range is affected. As you can see, it's being reflected. So usually it's above the asymptote, now it's below. So see how it's being reflected? Now let's go ahead, because of the negative. Let's go ahead and write the transformation. Let's do the range first. So it's going to be from negative infinity to the asymptote. And since we have a negative, we saw the reflection. And since h is negative 3, so it moved to the left 3, and the k is negative 5, so it went down 5. Now go ahead, try the last one on your own. So my y is equal to 4. It's my horizontal asymptote. Since the a is positive, then I know that the range and the domain. The domain is always going to be from negative infinity to infinity in every single problem. The range is going to be from the asymptote all the way up to plus infinity. However, if there is a negative, then it would be from negative infinity to 4. The transformation, since h is 1, so it's going to move to the right 1. Since k is 4, then it's going to move up 4. Now let's go ahead and get some points to be able to graph it. So let's say that x is 1. So 2 to the power 1 minus 1 would be a 0 plus 4. So that's a 1 plus 4, which is a 5. And then let's say that x is 2, because I don't want a 0, because if it's a 0, then 2 to the power negative 1 would be what? Half. So I don't want a half in my answer. I'm going to just put a 2, so 2 to the power 2 minus 1 would be a 1 plus 4, so that's a 6. So let's go ahead and plot the horizontal asymptote, which is y equals 4. And I'm going to plot the point 1, 5 and 2, 6. And I'm going to graph the line, the exponential graph. It's going to be, as you can see, above the asymptote, and that's why the range is from the asymptote all the way up to infinity. Now, I do hope that this video was helpful. I would expect you now to do the practice sheet on your own.